Okay, friends, welcome back. I want you to kind of ask yourself before we begin, what is our objective for math today, right? Think about it. And if you said today we are adding mixed numbers, yes. Okay, ding, 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 you got it. And so mixed numbers meaning we have two addends and they're both mixed numbers. And what that also means is that you have whole numbers with a fraction making a mixed number, right? All these, this and this are both greater than a whole, and so it is represented as a mixed number. Alrighty, let's jump right in. So I'm kind of going to walk you through exactly what this morning's video walked you through the first time, and I'm going to show you something a little bit different. Alright, so let's get started. We have 6 and 5/8 plus 5 and 5/8. I'm going to rewrite this in a way where we are expanding this and we are rewriting it as to what it could also mean. And so notice that I'm writing 6/8 is the same thing as saying 6 plus 5/8. And if we're trying to add it with our second addend, it's also the same thing as 5 plus 5/8. Okay, so we're trying to figure out how to find the sum of this expanded form, right? Equation. And so what I like to do is I like to think of first my wholes, right? And I think to myself, well, I know 6, friends, plus 5 is what? I'm going to first add my whole numbers. And I know 6 plus 5 equals, at the sound of my snap, 11, okay? Next, I'm going to rewrite this and express it as, well, now that I have 11 as my whole, I'm also going to think, well, if I'm adding the fractional parts, then I know my first fraction is 5/8 plus 5/8, and I think to myself, well, what is that? What would this be if it's 11 plus 5/8 plus 5/8? So now I want to add my fractional parts together. And we know in this case, all I need to do is add my numerators. When adding fractions, we do not add the, say with me, denominators. We only add the numerators, yeah? And so we have 11. Let's add those numerators. 5 plus 5 equals 10. And again, we do not add the denominators. All right? And so now that I have an answer of 11 and 10/8, right? We said it's not that that's not correct. However, if we want to represent this as a true mixed number where my wholes are listed and my fractional parts are listed, I can rename this fraction to show this. And I'm going to do so using a number bond, okay? Now, because my numerator is greater than my denominator, what does that tell us, friends? Right? Well, yes, it tells us it's greater than a whole. And so we're going to use 10/8 and we're going to decompose. And I want you to think to yourself, how would I write this if I were trying to express a whole and then some, right? Think to yourself. 2 and 1. Okay, awesome. So we can say 10/8 can be expressed as a whole by rewriting it as 8/8 because that's equivalent to 1. And then I think to myself, well, 8/8 plus what will give me 10/8? And yeah, 2/8. And so this allows me to rename my fraction as a true mixed number. If 8/8 is equivalent to a whole, then I know that 11 plus 1 equals 12. And then I can simply just write out the fractional part that needs to be included to write it as a true mixed number. All right? Now, remember in the beginning of the video, I said, well, I also wanted to show you something that's a little bit similar but different, okay? So in order to organize my board, I'm going to kind of draw a line. It's going to be a very quick, because it's super fast explanation, right? And so very similar. Think about it this way. If I want to add 6 and 5/8 plus 5 and 5/8, I'm going to think to myself quickly, well, I'm going to think 6 plus 5, let's start with my wholes, and I'm going to express this. 11. Now, I'm going to use 5/8, and I'm going to think to myself, well, if I have 5/8 of a whole, how many more 8s do I need in order to have another whole? That means what would the next whole be after 11? 12, right? And so, in order to go from 11 to 12, but remember, I only have 5/8. Then what this means is 5/8 plus, and I think to myself, well, 5/8 plus 3/8 will give me 12. However, guess what? I'm kind of missing the rest of my adding, right? If I only added 3/8 to my, if I only added 3/8 to my 5/8, but I have 5/8 to include, then it's thinking to myself, well, I'm not accounting for the 2/8 that's still there. And so I can say this would be rewritten once again as 12 and 2/8. Okay? So that's another way of thinking about the same work we just did. All right? Hope that was a little helpful, and I look forward to seeing you later for our math hangout.